Hello, good evening, everybody. Today we start our course for the derivative, a second video, and we're going to talk about derivative and optimization. We're going to do a couple of, for example, a sheet metal, and the second exercise, it's about a box. We made a box with a sheet metal, and we calculate, we use our knowledge, what we know in we use our mathematics tools to manufacture. Okay, and after that we're gonna have a folder of MATLAB with about the exercise, and Solidworks and Catia v5. It's not important, but you should see it now how it works. Okay, now we start with our course. So in last video we have talked about a rate of change. You're gonna see something. It says all is related. Rate of change. The last video they have a relation with the derivative today, and derivative today gonna have a relation with differentiation next week, and differentiation with development limited. All have a relation with scientist calculus. So scientist calculus about 70%. It's about derivative, differentiation, development limited, matrix, and it's more than 70%. So it's not only important for mechanic, but in future for the scientist calculus. I mean element finite. Okay, we start with our exercise. If this result exists and he is in R and he is a function of x, we are talking about derivative. Okay, if our result exists and is in R and is function of x, we are talking about derivative. Okay, this is all the story. And we have delta x, delta f, and delta x. This is rate of change medium. Okay, this is our story. Now we're going to do a couple, for example, to explain it, to let it clear. Minus 1 plus 1 x minus 1 0. Our function now is limit when x0 tends to 1 x squared plus x plus 1 x minus 1 x minus 1. This one there you go. So we have limit when x0 tends to 1 x squared plus x plus 1 equal 3. Now put x2 minus 8x plus 12 equal 0. We need a root, So delta equal and they see development of the sheet. Okay, because tool is like that. It's like that. Okay, it's like a tool. And here, for example, when you cut with the press, because it's about 2 millimeters the sheet. So, and then tolerance, it's not very too much precision, because more precision, more expensive. So it's normal precision. So interval of tolerance, we are talking about ISO, it's between 9 and 10. It means ET 9 or ET 10. It's not very precision tolerance. Okay. That was how we use. After that, look at now. Our curve is not good. Now we have some steps here. It's why I have choose 0.1. It's better, no? It's perfect curve. Okay. It's perfect curve. That's it. It's already show you how your first step, or show you how you do with the function. No, it's very important to have your function. You should customize yourself to work with the function. Okay. Okay. So that's it. Only we have start. It's okay. Okay. So C-Matlab. Okay. Now, for example, if you want to close, what you do, you weld, for example. You're going to weld now. Weld corner. Okay. Fix here. Okay. X. So superficie equal a square 16 max. Okay. Superficie maximum is that. Tangent, no? Okay. Tangent, and we're going to show another option. For example, here radio. For example, I reduce the radio to 2. For example, 2. Okay. I have radio 2. Our folder here.